Okay, welcome back to the 5.5 notes, and we're starting page 2. Okay, so what we have here in this first problem is f of 9, and as you see up here, f is defined as to be a function that adds 5 to numbers. So first thing to do is to write it with a little pocket for the x, and we're going to put a 9 in there. Oh, wrong tool, excuse me. We're going to put a 9 in there where it says x right here. And that's a pretty easy one. It just gives 14. So f of 9, the answer you get when you plug 9 in is 14. And you can be more specific. The answer you get when you plug 9 into the function whose name is f is 14. Okay. The next one, we're going to plug 9 into the next one, and you can see we're talking about this one now. And 9 plugged into that one. We're going to put 9 in those little slots. And when you do that and start doing some calculations, 9 times 9 is 81. We'll get the ball rolling. 2 times 9 is 18, minus 5, and the grand total of 94. Okay, next we're going to take the number 1/2, and we're going to plug it in this one right here, g of t. So where it says t, you got to put the number 1/2. So I've prepared that here. You can see I've got a squared times 2 and a minus 5, just like it says up there. But we're going to put 1/2 in here and 1/2 in for the other variable. Once we've done that, you just do the calculations. 1/2 times 1/2 is 1/4. 2 times 1/2 is 1, and taking away 5 gives this decimal number here, negative 3.75. You could, of course, put that in other formats like fraction form. Okay, we're moving on to the next function, this one here, and what h does is subtracts the number from 50 and then takes the square root of it. So let's get the ball rolling here. I've got it set up. We're plugging in the number 14, so let me put in 14 there. And then once I've done that, you do the inside first. 50 minus 14 is 36, and then the square root of 36 is just 6. Okay, problem 7 uses k, and k is defined over here. It's a fraction where the numerator is the number plus 9, and the denominator is 3 minus the number. So let's get this thing going here. I'm going to set it up here, and we're going to plug in the number 6. When you do that, you get 6 plus 9 is 15 on top. You get negative 3 on the bottom. Simplifies to negative 5. Okay, we're going to use function h next. You see how the name helps me identify the one we're going to use on problem 8. And we're going to take 50 minus 54 with a square root over it. And you may have anticipated this. There's going to be a little bit of a problem with this one. If you take 50 minus 54, you get a negative under a square root. If we were allowed to use the imaginary unit, we'd be fine, but we're not doing that, so we'll just write undefined because you're not supposed to put imaginary numbers in these problems. Okay, k of 3, I'm not going to keep going back up there. You're going to have to look at the definitions at the top of the page on your copy. Well, I'll go back up one more time here. If you need to write those down somewhere, all 4 of these functions up here, go ahead and do that. These guys up here, we're going to be using them for a few more problems down here. All right, so k of 3. Let me first of all set it up here. K adds 9 to the number to get the top. And so 3 plus 9 is what that'll be. And then on the bottom, it subtracts it from 3. And we're going to run into some trouble here. You'll see in a minute what I'm talking about. You get 0 on the bottom, and that's undefined. Okay. The next problem here uses both f and k, and it plugs different values into each of them. So we're going to uncover the f. F goes adds 5 to the number, so let's just put in -1/2 there. And then the k adds 9 to it. We'll put a -1 there and a -1 there. Let me get that -1 showing a little better. And when you simplify those, you get 4.5 for the first one, and 8/2, which is 8/4, which is 2. So that's 4.5 plus 2 is 6.5. All right, another example of this, we're going to be plugging n into function f and also into function g. So I've got it set up here. F is the one that adds 5 to the number, so we're going to plug n in there. N gets plugged in. Same thing over here, also n. And so when you do the math over here, you get n plus 5, n squared plus 2n minus 5. I've just kind of cleaned it up a little bit there, actually. And that comes out to be n squared plus 3n. Maybe you'll notice that the 5 and -5 cancel off. Okay, we got a little twist on this next one. We're going to do g of, and we're plugging in an expression 2n plus 3. So the first thing to do is set it up. You're going to need a little bit wider gap for the plug-in part. And what we're plugging in is 2n, let me write this a little better, 2n plus 3 and 2n plus 3. And if you look at the top, g squares it, doubles it, and subtracts 5. Adds them all up. So now it's just number crunching time. Well, expression crunching, I guess you'd say. If you take 2n plus 3 times 2n plus 3, that's going to give you this part right here. And then the rest of it, I think, is a little easier to see. And once you're done with that, you get your like terms together, and it looks like, yeah, that's right. It looks like that. Okay, for a second there, I was kind of doubting my own work there. All right, I want to highlight a mistake that I hinted at on the bottom of the previous page. If you look at this problem here, somebody's putting 5 in for the x's in function g, and they've done it correctly. They're squaring the 5, 2 times 5. They've done that line all correct, okay? And these calculations are good. This is good. And they finally get down to here, and everything's perfect. And then they wreck it. On the left-hand side where it says g of 5, you don't want to think of that as g times 5. If you do, you'll be tempted to do this mistake here, dividing both sides by 5. And when you do that, you've wrecked a beautiful answer, and you get nonsense at the bottom. The name equals 6. G equals 6. No. G of 5 equals 30 is the right answer. So you have to avoid that mistake, and I see it a lot when I teach this section. So hopefully you understand that when it says G parenthesis 5, it's not G times 5, and because it's not times 5, you shouldn't be dividing by 5 on both sides. Okay, we'll pick up on page 3 of these notes in a minute.